So when we read the question, let's actually read it and see how that looks like. So number of tadpoles, I'm not sure whatever it is, in the pond is triple every day. Okay, which graph best represent this relationship? Time and the number of tadpoles. So every day the number will be triple. So let's say day one, like let's say we have just one of them, and then day two is going to be just triple, which is going to be 3 times of this number, which is 3. And then if we like to find the day 3, that number should be triple compared to the previous one. So that should be 3 times 3. And then this was 1 times 3. And if you like to find the next one, so that should be 3 times 3 times 3. So you will just see that this is 3 to the first power. This is going to be 3 to the second power. This is 3 to the third power. And this was 3 to the 0 power. So whenever you are multiplying something to get the next number, that was like geometric sequence. But in terms of linear or exponential equation or functions, we say those are going to be exponential because the numbers, you are just increasing the days by 1 when you move on to the next day, but the number of tadpoles is going to be increasing by triple. Like that's not the linear. So that is not going to be the answer. So that should be the answer. So you can see how that looks like. But even though we got the answer, I just want to make it a little bit general statement. So we are going to be using it. So we start with day 1, which is 1 in this case. If you make it A, you can do that. So I'm going to make it A just to make sure you do remember. Let's say we have A. If you have a number of tadpoles in the first day, and then in the second day will be 8 times 3. Okay, and then next day will be 8 times 3 times 3, and then the last day, the fourth day will be 8 times 3 times 3. So if you continue this pattern, so in the nth day will be 8 times 3 to the n minus 1. So that is actually the expression that we have about the geometric sequence. So in this relation, if you like to say number of like tadpoles like A in the first day, and then the number of the total is going to be found by this formula. So we don't really need it at this point, but that is going to be if we need it. Okay, so that's the part B. So let's go ahead and check it actually. Okay, so that was correct. So I think we are good with that. So thank you. Thank you for that feedback. Okay, let's try the next one. Okay, so I just give you guys some time. Go ahead and try this one. So first of all, on the, I would say the first number we have x value was 2, and the next x value is 9, which is like plus 7. And then if you look at this next one, that is also plus 7, and this is going to be plus 7 as well. So the x values are increasing by a constant number. Okay, so you are just keep adding 7s to get the next numbers for the x values. But the y's are not that way. So y is like 4 to 8, 8 to 16, 16 to 32. So you just multiply by 2, and then you just multiply by 2. You just multiply by 2 to get the next one. If you are adding a constant value to get the next number, you are saying linear, but if you're multiplying, that's going to be exponential. So I'm going to say that will be exponential, because when you increase the x values by the same amount, the y values are not increasing by the same amount. So y value is just doubling. So that will be the exponential. But if you really want to find a general formula to represent these numbers, I'm going to do this way. So first number, like when you choose x to like 2, then your y value is 4. So maybe I can start with like a is equal to 4, because that's my first number, which is 4, if I want to write a general formula. And the common ratio between the first term to second term is just 2. So 8 divided by 4, 16 divided by 8, that is 2. The common ratio is 2. So by using these two, I can just say nth term. So it's going to be first term times r, which is 2 to the n minus 1, because I need to multiply the first term by one less number of 2's to get the next term. So if you are looking for the next term, so you multiply the first by 2. So that's why I should have just one less. So that might be my general formula. And then maybe I can go ahead and plug some numbers. So if I plug n equals 1, that should be 0. 2 to the 0 will be 1. 4 times 1 is 4. So that is going to be my first number for the y values. Okay. But again, so this is not really a geometry sequence because x and y are a little bit differently. But if you really want to find the expression for these y values, that is what I can say that. Okay. But if you like to find a general term for these numbers, then you can see that this is a linear numbers, or you can just say this is arithmetic sequence. So you can just see that the first term is 2, and you are just keep adding 7. So that should be 7 times n minus 1. So if you like to write it is general form, so that should be our first ones. But again, this is not what we need on this problem. So that is just exponential. Okay, so that is the answer. So let's actually check. Yeah, that was correct. So any questions? Are we clear till this point? So I think a lot of people did have the same answer, but if you are not one of those, so it's better to ask. Okay, so I think we are good. So let me move on then. Okay, try this one. This is a little bit trickier, which is I'll talk a little bit more. So I'm going to start with at least some numbers. Okay, so if I read the question, it says this guy will write like some books when I think when she's completing first book, she's going to get this much money for the first book. So I'm going to say, let's say for book number 1, this is the amount she's getting, so 75,000, which is a good number. But for after the second book, okay, let's say she's done with the second book, and then it says her cumulative earnings will double with each sequel of that series. So as soon as she's done with the second book, she's going to get the total amount of twice of the previous ones. Okay, so this was 75,000. So right now after the second one, so we should double this number. So again, I can just say it like 75,000 times 2. So her cumulative earnings after the second book is going to be twice of the first one, because we were told that she's going to get cumulative earning, which is like combined earning, will be doubled. Okay, so after the third book, okay, so her total earning, which is like cumulative earning, I can say this is like total earning, will double. So she had this much earning after the second book in total, and then I need to multiply this by 2 again. So that should be 75,000 times 2 was the earning in the past, like in the previous book, after the previous book was published, and then I need to multiply this by 2 again. So you see what's going on. So if you just continue this like this way, so after the third book, you have just 2 2s. After the second book, you have just 1 2 that you multiply with. So if you are having n book, that means you are going to have 1 less than n, which is n minus 1 times 2s. Okay, so which is going to give us 75,000 times 2 to the n minus 1, because we are going to have n minus of those 2s. Okay, so that should be our answer. So let's go ahead and write it. But before we write the answer, I just like to see if any questions pop up. So we really need to understand what's going on. Otherwise, those are all the choices like kind of like similar to each other. But it says the number of tickets fans will purchase will be a factor of 1.1. So this was the number of tickets after they maybe the first like they lost the game. When they lost the game, they got like 200 tickets, their fans. But if they are winning, the number of tickets will be like sold will be like increased by a factor of 1.5, 1.1. So which means if you multiply this by 1.1, you will get like 220 tickets. So when they are going to win the next game, the more people are going to get the tickets. So I should multiply this by 1.1, and then But as soon as you have the 220 tickets, let's say this is the number of tickets, like a, let's say multiply 201 1.1, so that should be 220 tickets. After they win the first game, there will be 220 people who will purchase the ticket. But now the next game, number of tickets will be sold will be still a factor of 1.1. So, but this was the number of tickets were already sold, and then we just like to multiply this by 1.1. So which is going to be another times 1.1 after the second win, after the third win, after the fourth win. So that will be increased exponentially. So that should be our answer. But right here, just addition, we never seen something like that. So some people like this is also similar, so we don't really add it. So we just, this is a factor of 1.5. So when we have like a times, let's say ratio to the n minus 1, we call this number a scale factor or a factorial number. Okay, this number is going to be the factor. So we just like to multiply with. So which is going to be our answer C. Okay, so let's check. Yeah, that was the answer. Okay, let's try this one there. So what we are going to be doing with this, so when you actually have something like this, I would plug some numbers for t's. Okay, so it says this expression is going to give us the area, which is going to be damaged by the fire as a function of minutes since the fire was discovered. So let's say t is 0. Okay, so if t is 0, so 1.15 to the 0 is just 1. 5 times 1 is 5. So when the fire just started, the area will be just 5 square meters. Okay, that is just like when t is 0. Okay, so actually, let me do this differently. So when t is 0, which is the time at 0, this expression is going to be 5 times 1.15 to the 0 power, which is 5. So that means there are 5 square meters. Okay, so I'm going to just try it. So this is the area before the fire just started. So, but if you just wait maybe 1 minute, because that's not a minute, so that should be 5 times 1.15 to the first power. So you will see that that will be 5 times 1 is 5, 5 times like 15, like 75. So that looks like 5.75 meters squared. So you can use calculator. So that is given. So I don't really need, I believe. But that will be after 1 minute. So this much area will be damaged by that fire. So now let's look at the meaning of those 5. So maybe we can just make it t is equal to 2. So that should be 5 times 1.15 to the second power. And then the next number will be larger than this number, so I don't really need to multiply, but you can go ahead and try it. But let's see how that looks like, the meaning of those. It has been 5 minutes since the fire was discovered. No, the time is just t. So these are the times, so 5 is not about that, so that is wrong. Okay, and the second one, the area damaged by the fire is multiplied by 5 each minute. So this might be okay because we are keep multiplying, but when you increase the minutes, actually we are multiplying by 1.15 each time. So this is not exactly that, because we had 1.15 and now we have 1.15. Now we have 1.15 times 1.15. So every minute it will continue. So we are multiplying 5 by 1.15. So the area damaged by the fire is multiplied by 5 each minute. So this is not correct. And the area of the 5 square meters has been damaged by the fire by the time it was discovered. So this was actually our first statement. So when you put a t equals 0, okay, so when you like say t is 0, which is the time, which is 0 minutes, so the area of the damage was 5 meters square. So that was already damaged area. So when they discovered it. So I would say that will be the much better answer. But again, the area damaged by the fire is multiplied by 5 each time. So this is wrong. So this 5 needs to be 1.15 1.15. If that is 1.15, then this might be correct, but that is given 5. No, this is going to be the answer for this question.